Hello everyone, I welcome you all to this lecture. In this lecture, we will see some of the basics related to electric charges. So, generally, electrostatics deals with study of forces, potential, and electric fields associated with a static charge. So, if you take bodies like glass, plastic, or silk, if you rub, they got electrified. So they acquire electric charge on rubbing. So there are two kinds of electrification, or there are two kinds of electric force. There may be force of attraction, or there may be force of repulsion. For example, if I take two charges, one is positive, let us assume, and the second one is negative. So then there will be force of attraction between those two charges. So if the charges are opposite in polarity, then there will be force of attraction between them. For example, if I am taking both are positively charged only, so both are positively charged, then there will be repulsion between the two charges. I hope it is clear. If the charges are both are positive or both are negative, similar, then there will be force of repulsion. If one charge is positive and another charge is negative, then there will be force of attraction between them. Okay? The charges are named as positive and negative by the American scientist Benjamin Franklin. An object possesses an electric charge, it is said to be electrified or charged. So if an object is gaining some electrons or losing some electrons, then we can say, if it is gaining electrons, then we can say it is charged or electrified. When body has no charge, if there is no charge in a body, then we can say that body as neutral. Generally, when the body got positively charged, if it is losing some of the electrons, then only get charged positively. If it is gaining electrons, then it is negatively charged. Okay? So we all know what are conductors and insulators, but we'll see what a conductor is and a insulator is. Conductors are the substances which allow electrons freely through them. So there will be free flow of electrons in a conductor. Examples like metals, humans, animals will allow free flow of electrons. They are good examples of conductors. If you take some other materials like glass, porcelain, wood, they won't allow electrons to flow freely through them. So they won't allow free flow of electrons through them. Those materials are called insulators. Generally, conductors allow free flow of electrons. Insulators doesn't allow flow of electrons through them. I hope you got what is a conductor and what is an insulator. Now we'll see some of the basic properties of electric charge. Before going to the properties of the electric charge, we'll try to understand one thing. For example, I have two charges. This is one charge and this is another charge, and they are separated by a distance. If the distance is very large, compared to those charges, the charged bodies are very small when compared to the distance between them, then we can assume that those two charges are point charges. Okay, now we'll see the different properties of charge. The first one is additivity of charges. For example, I have a system having n charges q1, q2, q3, q4 and so on qn. There are the charges in a system q1 to qn. If I want to know the total charge of the system, then the total charge will be sum of all the charges. So you add q1, q2, q3 and so on qn, you add them all, then that will be the total charge of that system. Okay, so the total charge will be given by q1 plus q2 plus q3 plus so on qn. The charge is having only magnitude, just like mass. We have mass have only magnitude, there is no direction for mass. Similarly, charge has only magnitude, there is no direction, but mass is always positive, but the charge can be positive or negative, that you have to remember. So charge may be a positive charge, charge may be a negative charge. So for example, if I am taking a system containing charges plus 1, plus 2, plus 3, plus 4 and minus 5 in some arbitrary units, let us assume all these are in coulombs. So if I want to find total charge of this system, then what I have to do? I have to add all the charges in that system. So if I add all of them, plus 1, plus 2, plus 3, plus 4 and minus 5, then I'll get 5 as the total charge. See, this 5, 4 and 1 will cancel, 3 plus 2 is 5. So the total charge of this system is 5 coulombs if I am taking all the units as coulombs. Okay, the second property is charge is conserved. For example, we have two bodies, those two bodies got interacted. Because of the interaction of these two bodies, the charge may be redistributed, but the total charge of the isolated system always conserved, that you have to remember. Okay, next one, quantization of charge. Experimentally, it is established that all free charges are integral multiple of basic unit of charge, and it is the basic unit of charge is denoted with the small e letter. Okay, so according to quantization of charge, the charge on a body is always equal to integral multiple of the basic unit of the charge. So Q is always equal to n into E. This n is always an integer, it must be an integer. Okay, so generally the charge of the electron will be written as minus C and charge of proton will be written as plus C. The fact that electric charge is always integral multiple of E is termed as quantization of charge. Just now we have discussed that. So what are the units for charge? In SI, the units for charge is coulombs. Generally this will be represented with the symbol C. Okay, 1 coulomb charge flowing through a wire in 1 second if a current is 1 ampere. So we all know that the current I is equal to dq by dt. So the current is rate of flow of charge. So if I want to say there is a 1 coulomb of charge that flows through a conductor in 1 second, then there will be a current of 1 ampere. So if I want to say charge is 1 coulomb, then there is a current of 1 ampere flows through the conductor in 1 second. Okay. So generally the charge of the electron is given by minus 1.602 into 10 to the power of minus 19 coulombs. If it is a proton, only the sign will be changing. Proton have plus 1.602 into 10 to the power of minus 19 coulombs. Let me go further. So there are about 6 into 10 to the power of 18 electrons in a charge of 1 coulomb. So how we got this? Let us see. We know that according to quantization of charge, Q is equal to N into E, where E is the charge of the electron, N is the number of electrons. So we know that here the charge is 1 coulomb is equal to N into what is the magnitude of the charge of the electron? 1.602 into 10 to the power of minus 19. Now if I want to know number of electrons N, you bring this side. Then 1 coulomb divided by 1.6 into 10 to the power of minus 19. This can be written as 10 divided by 1.6 into 10 to the power of 18. So 1.61, so it is around 6 point something. So I am taking near to 6. So 6 into 10 to the power of 18 electrons. That will be the N. So in 1 coulomb of charge, there will be 6 into 10 to the power of 18 electrons. Okay, let me go further. Okay, please. For example, if a body contains N1 number of electrons and N2 number of protons, if I want to find the total charge of that body, the total charge will be, see, N2 is the number of protons. Charge of protons will be denoted by E. N1 will be number of electrons and charge of electron is minus C. If I make E common, N2 minus N1 into E is the total charge of that body. Okay, let me go further. Now, whatever we learned so far, we try to recall or we try to apply in solving some of the objective questions. So let us see one by one. The first question is, among the following, the charge that does not exist on any type of charged body is. So see, this is 3.2, not 32. Just to change that. Any type of charged body is. So among the following charge that does not exist, you must underline this. So one of them is not possible. That's what he's saying. Let us see one by one. This is based on quantization of charge. According to quantization of charge, we know that Q is equal to N into E. So if I calculate for this N, this must be an integer. Then only that will be exist. Otherwise it won't exist. Okay. Now we'll see one by one. First option, if you take, see, the charge is 3.2 into 10 to the power of minus 19 is equal to N into what is E? 1.6 into 10 to the power of minus 19. So if I do that, just this minus 19 will cancel. N is equal to 3.2 by 1.6. 1.61 ja 1.62 ja, N is 2. This 2 is a integer, so this is possible. So option A is not our answer because it is a possible. He is asking not possible, does not exist. Okay. So now we'll check for the option B. Option B is given 6.4 into 10 to the power of minus 19 is equal to N into 1.6 into 10 to the power of minus 19. So this 10 to the power of minus 19 minus 20 cancels. 1.6 ones are 1.64 are. So n is equal to 4. This is also an integer. Now we'll see option C. Option C, he is given 9.6 into 10 to the power of minus 20 is equal to n into 1.6 into 10 to the power of minus 19. So 10 to the power of minus 19, we left with 10 to the power of minus 1 here. 1.61 are 1.66 are. So 6 n is equal to what we are left with, 6 divided by 10, that is 0.6. So this 0.6 is not an integer, so this is not possible. This charge doesn't exist. So according to his question, answer is option C. Let us check the option D also. Option D, he is given 9.6 into 10 to the power of minus 18 is equal to n into charge of electron is 1.6 into 10 to the power of minus 19. So 6 is 10 to the power of minus 19, 10 to the power of minus 18, we'll get 10 to the power of minus 1 here. If you bring this 10 to the power of minus 1 here, this will become multiplication. So n is equal to 60. So it is also a integer. So except C, everywhere we are getting n as a integer. According to quantization charge, n must be a integer. So only one option we are not getting integer, that option will be the answer. Okay, option C is the correct answer. When a number of charged liquid drops coalesce with the following quantity does not change. Which of the following quantity does not change? So here some liquid drops coalesce each other, then what quantity will not change? It is directly property, the charge is conserved. So option A is the correct answer. So this question is assertion and reason type. What assertion says? Half charge of an electron does not exist. So we know that according to quantization of charge, Q is equal to N into E. If the charge is half, this Q becomes 1 by 2, or Q is equal to 1 by 2 into E. So this must be an integer. This 1 by 2 is nothing but 0.5. It is not an integer. So that doesn't exist. This kind of charge doesn't exist according to the property of charge is quantized. So now we'll see the reason. The reason says that electric charge is quantized. Yes, this is the correct reason. So option A is assertion is true and reason is also true. Electric charge is quantized. We just saw the properties of electric charge. So both A and R are true, and R is correct explanation of A. So option A will be the correct answer for this question. Let us go further. A solid sphere will carry more charge than hollow sphere of same radius. You must underline the same radius. See, we have two spheres. One is hollow, another one is filled. So it is a solid sphere. Okay. Now he is saying solid sphere will carry more charge. Charge on this solid sphere is more when compared to this hollow sphere. It will be false. That won't be correct. Why? Because the charge will be deposited on the surface, distributed on the surface of the body, not inside. So both are of same radius, then surface area of the hollow sphere, surface of area of the solid sphere is same. If the surface area is same, the charge is also same. For example, if he asks, one is a cube, another one as a sphere, then this surface area is different from this, then there may be a possibility one surface may have more charge than other if there are two different surfaces. Even if the radius is not same also, then there may be a possibility. Okay, I hope it is clear. Now next question, plus q plus 2q plus 3q plus 4q up to plus 20q charges are situated at coordinates 0, 0, 1, 0, 2, 0 up to 20. What is the total charge stored in the system? So this is the property of total charge. So we know that according to total charge, if I want a total charge of a system, just I need to add all the charges. So I am adding q plus 2q plus 3q plus 4q plus so on up to there are 20q. So if I make a q common here, what I'll get? 1 plus 2 plus 3 plus 4 plus so on plus 20. So the total charge is equal to q into, so there are n numbers, the sum of n numbers will be given by n into n plus 1. So here there are 20 into 20 plus 1 is 21 divided by 2. So 2 ones are 2 tens are. So the total charge is 210 into q. So is there any option? Yes, option B is the correct answer for this question. I hope it is clear. Just add all the charges. Okay, let me go with the next question. So I hope you are able to understand this, why I have written 20 into 21 by 2. Sum of n natural numbers, 1 plus 2 plus 3 plus so on, n numbers are there. Then sum of them numbers will be given by n into n plus 1 by 2. Here n is 20. So 20 into 20 plus 1, that is 21 divided by 2 I have written. Okay. A charged conductor has its charge only on its outer surface. This statement is true for which of the following? So irrespective of the shape of the conductor may be any shape, always the charge will be distributed on the surface of the conductor only. So this is true for all conductors. Okay. Which one is not the property of charge? So we have just seen different properties of charge. Once we go through all the options, we can eliminate one of them. So let us see. Option A, charge is additive. So this is the first property of the charge that we have seen. Charge is conserved. This is the second property that we have seen. Quantization of charge. Q is equal to NE. We have solved some of the numerical problems also on this. So this is also property of the charge. We never saw that a charge is self-destructive. Nowhere we have seen this kind of statement. So absolutely option D is the correct answer for this. Actually, here he is asking not the property. So all these won't be the answers. So option D will be the answer for this question. Okay. So when you are reading the question, you have to read properly. Sometimes he is asking not. If you forget to read that not, you may end up with a different answer which was wrong. So always try to read the question once or twice and try to understand the question properly. And even when you are going through the question, read all the options. Sometimes there may be option A and option B both are true. In the option D, he will give both 1 and 2. In such cases, you may directly, by reading first option itself, you tick the answer, you will end up with a wrong answer. So always try to read the question properly and try to solve. Thank you all for your patient hearing. I would like to stop here. Thank you.